Welcome to Let's Get to the Marks. Okay, this is an A-level chemistry question on redox equations. So first of all, 3.4, deduce the oxidation state of the chromium ion in Cr2O72-. So first of all, how do you work out the redox state? You just always assume that oxygen is -2. There's only one time when it isn't, when it's with fluorine. Other than that, it will always be -2. So there are 7 oxygens. 7 times -2 is -14. We know that Cr2 therefore must be +12 because there's an overall charge of -2. Plus 12 divided by 2 because there's 2 CRs. Each CR must equal +6. And that will get you a mark. Now let's look at 3.5. Iodide ions can be oxidized to iodine using Cr2O72- ions. Deduce the half equation to show the oxidation of iodide ions to iodine. So we know from the equation that we've got iodide ions on the left and iodine on the right. We know that iodine is diatomic. There's 2 of them, so I need to put a big 2 in front of my I-. We know that oxidized means oxidation is loss of electrons, oil rig. So on the right-hand side, I'm showing that loss of electrons, and we know that's going to be 2 electrons. Now we need to deduce a half equation for the conversion in acidic solution of Cr2O72- ions to Cr3 plus ions. So what we're going to do here is, right, Cr2O72-. I'm going to draw an arrow in the middle, and we know it goes to Cr3 plus ions. Right now, here comes the beauty. There are 7 oxygens. Whenever you have oxygens in a redox equation, you must put water on the opposite side. That's how you deal with the oxygens. There are 7 oxygens, so I need 7 water molecules to balance those 7 oxygens. Now I have 14 hydrogens, so I'm going to add 14 hydrogen ions, and we had a clue from that because it was an acidic solution. It meant hydrogen ions were hanging about. I know I've got 2 chromiums on the left, so I need 2 on the right, so I put a big 2 in front of the Cr3 plus. Then what I do is I add up the charges and I go 2 times 3 plus is 6 plus. I come to the left and I find that I've got a -2 ion and 14 positive hydrogen ions, so I've got 12 plus. I need to add something to electrically balance my half equation. So I'm going to add 6 electrons here, and those 6 electrons are going to reduce the positive charge on the left side to 6 plus. Now both sides are electrically balanced, and this is what you do in all redox. You make sure it's electrically balanced on both sides. So 6 plus on both sides. That's cool. Now what I need to do is combine the 2 half equations to write an overall equation. So what we're going to do here is we need to realize that I have 6 electrons down here at the bottom, and I have 2 electrons at the top. By using the amount of electrons in each half equation, we can write the overall equation. So I need to multiply the top half equation by 3, and by multiplying the top by 3, it means that both half equations are now balanced. So what you need to do is just bring the reactants together and products together from both half equations, but bearing in mind that when you put the top reactants down from the first half equation, we've times them by 3. So instead of 2 iodide ions, I now write 6 iodide ions. I still stick to Cr7O2 minus, Cr2O7, because that's the bottom half equation which we didn't multiply, and 14 hydrogen ions, we didn't multiply that. We know the electrons are going to be 6 on each side, so we're going to cancel them out because we've balanced them. I need to 3 times the iodine because that's part of the first half equation that we times by 3. The 2 chromium 3 plus ions come from the second equation that wasn't multiplied, and so do the 7 H2Os. And boom, we've balanced the overall equation. So guys, I hope that was helpful. One thing that you should always do is electrically check your equations balanced. And if we do that, we can see it's +6, the charge on both sides of the overall equation. So boom, it's done. All right, guys, what I was going to say is don't forget, sharing's caring. Hit the like, punch up the bell, subscribe. Let's get to the marks.
You're still here? It's over.